Hi kids, today let us look at chemical reactions in a different manner. Let us understand a bit about chemical equations and mole concept. So what is a chemical reaction? We have already studied about chemical changes, right? So chemical changes are nothing but chemical reaction. So when does it happen? When a bond is formed or broken between two atoms is when a chemical reaction happens. And how do we represent it? We represent it using chemical equations. Any chemical equation will have an arrow mark which shows the direction in which the chemical reaction happens. On the left hand side of a chemical equation, you can see reactants that interact with each other to give you products. On the right hand side, you can see the products. You do have certain numbers here, correct? So these numbers are nothing but called as coefficient. Coefficients are necessary to showcase the number of molecules involved in a chemical reaction. And it is also used to show balance in a chemical equation, in turn in the chemical reaction. What does this signify? It signifies law of conservation of matter, which states that matter can neither be created nor destroyed. So this is applicable in all chemical reaction. So let us see if it is seen here too. So in here you can see a particular chemical reaction where methane and oxygen react with each other to give you carbon dioxide and water. So let us see on the right hand side what are the different types of atoms we can see. We have carbon here, we have hydrogen, and we have oxygen. So this is carbon, this is hydrogen, and this is oxygen. This is carbon, correct? So we have one carbon out here and one carbon on the right hand side also. So therefore carbon on each side is the same. Then let us see how many hydrogens we have. We have 4 hydrogens on the left hand side and 4 hydrogens on the right hand side. So we have 4 hydrogens on the left hand side. On the right hand side too we have 4 hydrogen. Then let us see how many oxygens we have. So there are 4 oxygens on the left hand side. On the right hand side we have 4 oxygens. So if you see the number of atoms, the number of different atoms on both sides are exactly same. So that just means that the same number of atoms are present on both sides of a chemical change or both sides of this arrow mark. So only change is that they interact with each other and the arrangement is slightly changed in the right hand side. That is because of the bond formed or bond broken between two reactants. Let us try to understand law of conservation of mass using an example. In here you can see a flask containing calcium chloride solution, and it also has a test tube containing sodium sulfate solution. Also note that this flask is sealed off to avoid anything from coming out or going in. When this whole apparatus is weighed, you can see that it is 300.23 grams. And when you tilt the flask to start off the chemical reaction, you can see the products being formed. So calcium sulfate precipitate is formed in NaCl solution. So when this whole thing is weighed again after the chemical reaction, you can see that it is 300.23 grams. So if you compare both before and after the chemical reaction, you see that the mass is the same, hence it reiterating the law of conservation of mass. You can see the chemical reaction out here, wherein calcium chloride interacts with sodium sulfate solution to give you calcium sulfate and sodium chloride. Let us try to understand relative atomic mass and relative molecular mass. Even before we get to it, let us try to recall what is mass number. It is nothing but the total number of protons and neutrons present in an atom, correct? So in that case, hydrogen has one proton and no neutrons, hence its mass number is 1. Nitrogen has 7 protons and neutrons, hence it is 14. Sodium has 11 protons and 12 neutrons, hence it is 23. Carbon has 6 protons and neutrons, hence it is 12. Oxygen has 8 protons and 8 neutrons, and hence it is 16. So what is relative atomic mass now? It's just another way of saying how heavy different atoms are in comparison with carbon 12 atom. That just means that if you take a carbon atom and make it into 12 pieces, one piece is going to represent a unit called as the unified mass. And from now on, we are going to use it and we will be representing it as in the form of U by writing U. We also know that one proton and one neutron is equivalent to one unified mass. Hence, it's easy to know the relative atomic mass. If you just represent the atomic mass or the mass number using the unit U, then it is nothing but the relative atomic mass, to put it in a simple term. So in here, so therefore the relative atomic mass of hydrogen is 1U, nitrogen is 14U, sodium is 23U, carbon is 12U, and oxygen is 16U. Now let us look at relative molecular mass. Relative molecular mass is nothing but sum of the relative atomic masses of each atom within the molecule. Let us look at it using an example. Let's see the molecular mass, relative molecular mass of carbon dioxide. There is one carbon and carbon's relative atomic mass is 12. So therefore it is 1 into 12 plus you have 2 atoms of oxygen and oxygen's relative atomic mass is 16. So therefore 2 into 16. So it is 12 plus 32, which is going to give you 44U. Now let us look at another example. Let's try to find out the relative molecular mass of water. So it has 2 hydrogen atoms, so therefore 2 into 1U plus 1 into 16U, which is nothing but 2U plus 16U. When you add it up, you're going to get 18. Let us try to understand what is a mole. Even before we start off, let us make certain things clear. Atomic mass or mass number is going to be represented as capital A. Relative atomic mass is going to be represented as capital A and with the subscript R. Relative molecular mass is going to be represented as capital M with a subscript R. Mole of any substance is that quantity in number having mass equal to its atomic or molecular mass in grams. So for example, carbon has an atomic mass of 12. That just means that its relative atomic mass is 12U. And if I take 12 grams of the carbon, I'm going to get 1 mole. And 1 mole of any substance will have 6.022 into 10 power 23 particles of it, of that particular specimen. And it just means that 1 mole of carbon will also have 6.022 into 10 power 23 atoms of carbon. And this particular number is termed as the Avogadro number. Let us look at few more examples. Let us take oxygen atom. So oxygen atom, atomic mass is 16, relative atomic mass is 16U. If I take 16 grams of oxygen atom, it just means that I have 1 mole of oxygen atoms. Let us look at oxygen molecule. In case of oxygen molecule, we need to consider relative molecular mass. So it is going to be 2 into 16 units. Unified mass is equal to 32U. So if I take 32 grams, I'm going to get 1 mole of oxygen molecule. Look at how different a molecule of oxygen and molecule of atom can be when it comes to moles. So let us look at a compound. And here again we will take the relative molecular mass, so which we already looked at, and the relative molecular mass of water is 18U. It just means that if I take 18 grams of water, I'm going to get 1 mole of water. So again I'm going to repeat it. 1 mole of any substance for that matter. For example, 1 mole of oxygen atoms, 1 mole of oxygen molecule, or 1 mole of water molecule is going to definitely have 6.022 into 10 power 23 particles of that particular specimen, and that is nothing but Avogadro number. Now let us look at why we needed a unit like mole. So when I say 1 dozen of something, I mean 12 of it, right? So if I say 1 dozen eggs, I just means 12 of eggs, right? So just like that, mole is a concept, or mole is a unit which represents 6.022 into 10 power 23 of something. That's about it. So let us take an example. Let's try to understand with an example here. Two molecules of water will split into two hydrogen molecules and one oxygen molecule. So if at all we consider it in unified mass, then it just means that 36 units of water molecule is going to give me 4 units of hydrogen molecule and 32 units of oxygen molecule. If I need to do this particular experiment in my lab, I can't literally weigh it in unified mass or U, because it is too small to be considered, or even too very small to even measure. So therefore it's easier if I consider it as moles. So if at all I'm considering it as moles, then I would consider it as 2 moles of oxygen, 2 moles of water. When I split 2 moles of water, I'm going to get 2 moles of hydrogen molecule and 1 mole of oxygen molecule. Then that means to say I just need to weigh 36 grams of water, and I'm going to get 4 grams of hydrogen molecule and 32 grams of oxygen molecule. Relative atomic mass or relative molecular mass in grams of any substance is going to give you 1 mole of that particular substance, and it will have 6.022 into 10 power 23 particles of that particular substance. So here you have formulas to find out the number of moles or number of particles in a substance. Let's see if we can make it a little easier, and let's try out these problems. You need to find out the number of moles in 4 grams of hydrogen atoms. Let's try and do that. So atomic mass of hydrogen is 1, and relative atomic mass of hydrogen is going to be 1U. So therefore 1 gram of hydrogen atoms is going to give you 1 mole. If 1 gram of hydrogen atoms will give you 1 mole, let's say 4 grams is going to give you X moles. So cross multiply, and you're going to get 1 into X is equal to 4 into 1. So X is going to be 4 moles. So 4 grams of hydrogen is going to give you 4 moles of hydrogen atoms. So let's try the second problem, wherein you need to find out the number of moles in 6 grams of water molecules. Relative molecular mass of water is going to be 18U, which we have already seen before, and therefore 18 grams of water molecules is going to give you 1 mole. So if 18 grams is going to give you 1 mole, then 6 gram is going to give you, let's say, X moles. So cross multiply, and you're going to get X into 18 is equal to 6 into 1. So keep X as it is and bring down 18, and you will get X is equal to 6 by 18, which is nothing but 1 by 3, which will give you 0.3 moles. So 6 grams of water molecules is nothing but 0.3 moles of water molecules. Let's look at the third one. In here, you need to find out the mass of 0.2 moles of oxygen atoms. So for oxygen atom, the atomic mass of oxygen is 16. So therefore, relative atomic mass of oxygen is going to be 16U. Therefore, 1 mole is going to have 16 grams of oxygen atoms. So if 1 mole is going to have 16 grams of oxygen atoms, 0.2 moles will have, let's say, x grams. So if you cross multiply, you're going to get x into 1 and 16 into 0.2, and 16 into 0.2 is 3.2 grams. So therefore, mass of 0.2 moles of oxygen atoms is going to be 3.2 grams. Let us look at the last example, wherein there are 3.011 into 10 power 23 atoms of N atoms, nitrogen. And we need to find out the number of moles. So 6.022 into 10 power 23 of any substance is going to give you 1 mole, right? So it holds good here also. So 6.022 into 10 power 23 of N atoms is going to give you 1 mole. Therefore, how many moles will 3.011 into 10 power 23 give? So here, let's say x mole. So when you cross multiply, you get 6.022 into 10 power 23 into x is equal to 3.011 into 10 power 23 into 1, which is nothing but x is equal to 3.011 into 10 power 23 and divided by 6.022 into 10 power 23. These two will get cancelled and you're going to get 0.499, which is approximately equal to 0.5 moles. So therefore, half of 6.022 gave you 0.5 moles of nitrogen atoms. Let's look at the summary. Reactants interact to give products in a chemical reaction. Law of conservation of mass states that mass can neither be created nor destroyed. Relative atomic mass is the average mass of an atom as compared to 1/12 the mass of carbon-12 atom. Relative molecular mass is the sum of the relative atomic masses of atoms in a molecule. Mole of any substance is that quantity in number having a mass equal to its atomic or molecular mass in grams. 1 mole of any substance will have 6.022 into 10 to the power of 23 number of particles, and it is called as the Avogadro number.